Physics video. Yay! Mass is the amount of matter that makes up an object. No matter where you are in the universe, your mass will not change. Weight is a force generated by gravitational pull on an object. After doing my research, I've learned that Neil Armstrong in 1969 weighed 170 pounds. This calculates to be 756.2 newtons on Earth. I know that mass equals the weight in newtons divided by the acceleration due to gravity, which is 9.8 meters per second squared on Earth. Given that its weight is 756.2 newtons, I divide that by 9.8 meters per second squared. This gives me 77.2 kilograms. This is all still while on Earth. On the Moon, his mass remains at 77.2 kilograms. The acceleration due to gravity on the Moon is 1.622 meters per second squared. The acceleration for finding weight or force of gravity is mass 77.2 kilograms times acceleration due to gravity 1.622 meters per second squared. From this I get 125.2 newtons, which when converted to pounds is 28.1. This is how much Neil Armstrong weighed on the Moon. A scalar quantity consists of magnitude only. This means any quantity or amount that has only to do with its amount or magnitude. Scalar quantities do not include direction. Examples of this include speed, temperature, volume, and time. A vector quantity is one that includes both magnitude and direction. Vector quantities are used in equations of vectors that go in specific directions. Direction can be either cardinal directions like north, east, south, and west, or numbered qualities like positive or negative. Scalar quantities are measured by position versus time graphs, while vectors are measured by velocity versus time graphs. Accuracy is like throwing a dart at a bullseye. Precision is like throwing 3 darts in the same space on the board. Precision doesn't have to be accurate. Precision is all about grouping. Almost all competitions have something to do with achieving both accuracy and precision. Newton's first law states that an object in motion tends to stay in motion, while an object at rest will remain at rest until acted upon by an outside force. Inertia is the ability of an object to resist motion due to its mass. This is why, as you can see in the picture, as the bike hit the wall, the driver of the bike kept going. This is a scene from Con Air where Nicolas Cage drops the body of a dead prisoner out of a moving airplane. Ignoring air resistance, this is an example of free fall. Free fall is achieved when the only force acting on an object is gravity. The acceleration due to Earth's gravity is 9.8 meters per second squared. I can calculate the final velocity by the equation Vf equals Vi minus gravity times time. I know the initial velocity is 0 because he started the instant he was dropped. The time it took from the drop to the point of contact was 37 seconds. With the numbers plugged into the equation, you get 0 minus 9.8 meters per second squared times 37 seconds. This gives you a final velocity of 362.6 meters per second. Constant velocity is when an object not only remains at the same speed, but also in the same direction as it is a vector quantity. Constant velocity is represented on a velocity versus time graph as a straight horizontal line. The line shows that there is no magnitude or there's no change of magnitude or direction. As you can see on this particular graph, it is moving at a constant velocity of 200 centimeters per second. Acceleration is another vector quantity that is any change in speed or direction. If a ball on a string is swung around at the same speed, the acceleration changes. Also, when a car speeds up but stays in the same direction, acceleration changes. As you can see in this video, friction and acceleration go hand in hand. The tires need friction to move the car, thus accelerating from 0 to upwards of 100 miles an hour. A projectile is any object that can be thrown, fired, or launched, and that the only force acting on the object is gravity. The picture to the right describes the motion of a projectile. If an object is launched into the air at no height, it will hit the ground with the same force and velocity in which it was launched at. For projectiles, the only force acting on it is gravity. That is why a bullet dropped and a bullet fired will hit the ground at the same exact time, ignoring air resistance.